Hi, it's Paul. Let's look now at neuroendocrine carcinomas. So these arise from the diffuse neuroendocrine system and include a spectrum of different tumours, but we'll look at the kind of generalised features, and we'll be looking at lymph nodes, the usual basic features. And so these cells are carcinomas, so in arrangement they tend to form groups, but they also often have single cells. They have very tightly moulded groups, and they often form chains or vertebral columns, linear sort of arrangements of nuclei, which I'll show you. This is a typical low power PAP, and you can see there are dispersed cells, but there's also very messy, disorganised little groupings of cells as well. Low power, this could be lymphoma, it's so dispersed in this part, but if we look more closely, you'll see that the cells are actually kind of pooling together in places, and so they are actually forming some cohesive groups, such as these ones here in the middle. Another example here, and you can see how more clustered they are here. So lymphocytes shouldn't really do this in a smear, form these groups. They're not looking organised like adenocarcinoma because they're very tightly packed. So it's a very high INSI ratio. You can't really see cytoplasm around the cells at all, and they're like very sticky nuclei all held together. Notice how they're forming trabeculae or linear sort of arrangements here as well. There are quite a few single cells around. There's probably more variation even this size than one would normally see in lymphoma as well. Cytoplasm is usually very sparse on neuroendocrine tumours, particularly the poorly differentiated ones. So they have a very high INSI ratio. Cytoplasm is very hard to see on a pap stain especially, and so it produces a very indistinct, poorly defined edge to the cell. And generally speaking, they don't have as well a defined cytoplasm as lymphocytes, and they don't have that nice crescent of blue cytoplasm that you would normally see in a Giemsa stain slide of lymphoma. Having said that, my first example here looks a lot like lymphoma. So you can see the cells do have cytoplasm. It's not that obvious, but there's a little rim of cytoplasm around each of these individual cells, and it is a little darker towards the margin of the cytoplasm. So these cells here are looking really quite lymphoid. Notice, but there's a couple of elongate looking nuclei here that you wouldn't normally probably see in most lymphomas. Just notice while I'm here there are two mitoses here standing out, and the background often contains mitotic figures and apoptotic debris and necrosis, because these are often quite aggressive, rapidly proliferating tumours. This is a pap stain. You can see very little cytoplasm on this. It looks almost like bare nuclei, but in places I think you can see a little bit of fragile blue cytoplasm around the cells. But they're very tightly packed, as you can see, and forming again those sort of linear arrangements of cells. Nuclei are very characteristic in neuroendocrine tumours. So that degree of anisokaryosis varies according to the differentiation of the tumour. So carcinoids, which are well differentiated neuroendocrine tumours, tend to have less nuclear atypia than small cell carcinoma, for example. The nuclei are often a mixture of round, oval and elongate nuclei in the one case. They tend to have very hyperchromatic nuclei with stippled chromatin, so dotty they have what we call inconspicuous nucleoli, so they're sometimes apparent, but they're not large. And a key feature is nuclear moulding, so nuclei wrapping around each other. Here is a good group, so we can see that there's quite a lot of variation in size and shape of nuclei in this arrangement. Notice variation between those two, and then there are these linear chains of cells. So these are like almost vertebrae lining up like a vertebral column, and that's very characteristic of neuroendocrine tumours. Over here we've got tight moulded nuclei, and this is a good example of very finely stippled chromatin. So you can see lots of very fine dots in the cytoplasm here on the pap stain. Just looking around, you can see how tightly packed the nuclei are, so very high NC ratio. That granular material in the background is necrosis. And this is another case, again showing that stippled chromatin pattern, nuclear moulding, cells wrapping around each other. And yet another case, again really nice stippled chromatin, in this case variation size and shape, high NC ratio, possibly little nucleoli in some of these I'm pointing out, but great chromatin. So the pap stain is really useful in neuroendocrine tumours. We want to check out that there is stippling of the chromatin and that there are inconspicuous nucleoli present. On the other hand, air-dried Giemsers are really best to see moulding in, or even the air-dried parts of alcohol-fixed pap stain slides. Finally, a Giemser, you can see here this elongate nuclei right next to round ones, larger oval-shaped ones, and again that moulding forming linear chains of cells, really nice chain up through there. And if you look around, they're pretty much everywhere, these vertebral columns of nuclei. Notice there's a bit of stringy material here, and that is crushed nuclei. So these are quite fragile nuclei, and often you get that crush artifact present. Now you will see that sometimes with lymphomas as well, that are also fragile. So in conclusion, the differential diagnoses that most commonly arise with neuroendocrine carcinoma include lymphomas or lymphoproliferative disorders, and that is a difficult differential sometimes. So diagnosing neuroendocrine carcinoma in lymph nodes, for example, can be somewhat tricky, and often we'll use ancillary techniques, but important to look for those features I've just talked about that separate it from lymphoma. Another difficult differential sometimes is with a poorly differentiated squamous or glandular carcinoma and neuroendocrine carcinoma, and so identifying particularly the nuclear features is particularly important in those, including an absence of nucleoli.